In the last video, we looked into creating data types for our game, and we've revised them and looked into structs of how to generate cards. We also figured out that we can compare attributes of cards, and we'll now have a look in the more detailed game logic. That card. And obviously we now see a lot of things did not happen. Nowhere did the player actually decide what he was doing. Nowhere did they get cards. Nowhere did they run into picking up the cards and stuff. So we're at the beginning. And maybe one thing we should now think about is how would the actual game work. So the game has multiple phases. We first have to split the cards between the two players, and everyone gets 16 cards each. Then we decide who plays first, We could do this by doing a coin toss. We could also do the youngest player goes first, but we don't know who's younger because these are computer players. The next thing that we need to do is the first player will have a look at his card. So, and in this case, I'm not saying player 1 or 2, but the one who's playing. So, or maybe let's call it the active player. Active player will look at his card and pick a value to compete with. And for this, we maybe need to define what values are true. So for top speed, I would say higher is better. For liters per 100 kilometers, lower is better. Horsepower, higher is better. For range, higher is better. For weight, lower is better. And for cylinders, it's probably doesn't matter. It will just say higher is better. So we have some properties where you would win if your value is higher than your opponent's, and you would have some where it's lower. And so the active player will look at his card and pick a value to compete with. The passive player in this case will look at the value. Then we will compare who wins, and then the losing card goes to the winner deck. And that's actually an interesting thing. We split the cards between the two players, and we didn't tell it that we need to form a deck. So form a shuffled deck. So there's one card on top and one on the bottom. The losing card goes to the winner's deck bottom. Same for the winner card. And then next turn is the winner's turn. So adaptively, we will decide whose turn it is. It's always the one who wins. And if the first player in succession wins 16 times, player 2 doesn't even get a chance of playing. And that is what can happen, but it will not happen frequently because obviously your card is not always having the best option against every other car. So how would we do this? We would, we have these two cars, and obviously we said we wanted how many? 32 cards. And so we could now do car 1, 2, 3, 4, 5, 6, and so on. But maybe we just want a list of cards. We don't want to have individual variable names, but we want maybe like all cards. And all cards should be in here. And one way of doing this in Julia is by using the brackets. And these brackets, if I put in several values in here like this, now this is called a 2-element vector. And let's close this, and we can, in all cards, it's now a vector of type int64 with 2 elements. So a vector is kind of a list. It has 2 elements, and they are of type int64 because this is what I put in here. But we could also put in car1 in car2, and then this is a 2-element vector of cars. And this would be the car Mustang, and it would be the car Mini Cooper, the ones that we created up here. And if we can now even, instead of creating this car variable, we could take this, or we could make it in a way where we add the cars individually. So obviously we still need the 2 variables, and that's not what we want. So let's say all cards is an empty list, and we then create this one car, and then we want to add this car to our list, and we would do this by calling the push exclamation point function, which says put something into this collection, and the base would be all cards, and we are going to put the car in. We can test this by, let's move this aside, and let's comment this is list of all cards. It's a vector of type any, and the idea of type any means we don't know what is going to be in there yet. It can be anything. And now we create a car, which is just a variable car, and we can now push. And what push does is it takes this variable all cards and takes the element after that and puts that into the all cards array. And now if I look at all cards, I see it's a 1-element vector of any, which has, we can see this here as well, the type of the vector is called any, because in this here I could also push 1 all cards. I could put in a 2 as well. So this all cards allows any type of variable. It has now a car and it has a number 2. And so all cards is now kind of like a bag where you could put anything in. And that's probably not what we want. We don't want to accidentally put in something like name player 1 and now we have Alice in here as well. We don't want that. She doesn't belong in the deck. So we should try to enforce that all cards is a vector that has a type. And we could do this by saying vector of type car. And it doesn't work now because we have already created this variable. So let's kill Julia here. And let's start from the top. We have our 2 players, Alice, and of course now Julia needs to restart. She hasn't won yet. Bob is the name who hasn't won yet. The game has not ended yet, and these are our templates for our cars. We create an empty list of all cars, and if we look in here, it's a vector of type car. Interestingly, the result here is of type any, and that is because by the printout of this prints to the most generic type, and that is any. So what we really have, we see here, it's a vector of type car. And now if I add, this is a new car that I create, I can push that car. But if I now go here to the all cards and push maybe Charlie in here, I'll get an error. And let's see the error in all glory. It says method error cannot convert an object of type string to an object of type car. And that's because it's hard to convert the name Charlie into the structure here. We haven't told it how to do so, and it doesn't know how to do it automatically. And that is something what we want. If we know what we're going to put into our array, we should let Julia know what it is so it can help us find these mistakes that we do here. So we can push car into all cards, and if we look at all cards, we have this 1 element in here. And what we can now do is, wait, I didn't want to delete that. We can now take the Mini Cooper and put that into the variable car. Now the only car variable that we have is 1 car variable, and we can now push this car again into our all cards. And now we have a 2-element vector with 2 cars The first car is called Mustang, and the second car is called Mini Cooper. Without having two car variables, we just use this one variable. So we don't need more and more variables. We can do this again with a third car. Let's actually do this, why not? And let's call this a, what do we want? We have a Mini Cooper, we have a Mustang. Let's do a, I have no idea. Let's do a Tesla. No, that doesn't make sense. It doesn't use liters, so we cannot use electric cars. Let's use a, I don't know, BMW X5. Is that a car? It sounds to me like that would be a car. Let's make that a fast car that uses a lot of gasoline, and it is it has a lot of horsepower. It doesn't have that much of a range. It is kind of heavy, and it has 8 cylinders. And we can do this again, and now we have 3 cars in our list of cars with having only one car variable. So we can add additional car variables into this all cards thing. What we could also do is, without having this car variable, we could directly put this into the push variable. So we could directly, let's demonstrate this quickly. I could directly push into this array. The vector we sometimes call array, because that's how this has been used in other languages, exclamation mark, all cards. And here I could just create a new car and call this, let's make this a Nissan. I don't know, I have no idea of cars. Let's make this a sedan for people at home, with people with families. So this is a maybe a low top speed of 160. It uses only 6 liters per 100 kilometers. It has 85 horsepower. It has high range of 750. It has normal weight of 750, and it has 4 cylinders. I don't know. And I can directly push this car into this all cards array. So here we will have all cards. This is the cards that we have. We can figure out, by the way, programmatically, how many cards we have by calling length on all cards. No, it's not length, it's length. And that is 4. So by calling length on all cards, we can figure out how many cars we have. We could do car count, or let's call it cards count. It's actually cards. And we can now have the cards count. And we could use this by letting the user or the player or us know how many cards we have by calling the command println, as in print line. And in here we would write the deck has, and now we would want to add cards count, and we can do this by putting a $sign and braces, parentheses, cards count, cars in total. And if I run this, it tells me the deck has 4 cards in total. And depending on what I do here, how many cards I add here, I will have more cards in this list. And the way this writes is a little nicer, so let's put all the cars directly into this array and remove all these other lines. So we just have a list of, so every line is just one car. Obviously we could take this from a database, which we could do later, but let's, at this point in time, not do it. So let's take this car and put it in here. We don't need this. We don't need this. And now by just adding a line, we can add more cards from this all cards to the list of all cards. So here we say create all possible cards. It's kind of weird saying cards and cars. So this was just trying whether we can see who wins, and we could. So now we want to split the cards between the two players. We only have 4 cards. We don't have 32 yet. But that's the thing in programming. We don't have to have all of the data. We can use less, and we can try to make the approach as generic that it'll work with lesser cards as well. Actually, it's a good idea to test it with few options and then see how it scales later on. So what we're going to do is we need 2 stack of cards. So we need a deck player 1 and we need a deck player 2. And how would we do this? We have all cards where we have 4 of them. So we know that half of the cards is going to player 1 and half of the cards is going to player 2. So we want to pick a random set of cards from all cards and put that to player 1. And there's several options of how to do this. So let's see if you wouldn't know how to do this, how could you find help for this? So I'll put in Julia. And let's say take random elements from an array. You could also say vector from a vector. That's probably what you would know by now. How do I randomly select an item from a vector in Julia? Stack Overflow can be very helpful, and it says it's as simple as, if this is the array and you just say rand, you get a random element. So we could do rand of all cards, and it gives me one. It gives me the Mini Cooper. So the thing is, this is now, there's only 1 car for the player 1, and this one, okay, it works. Now it's the Mustang. Now it's a Mustang again, and that shouldn't happen. So it's kind of working, but it's not fully doing what we want to do. So we want to add cards to the deck, but we don't want to use them again. So how would we do this? And well, how would you do this in real life? You would actually repeat the same process over and over. You would give 1 card to person A, 1 card to person B, and then 1 to A, B, A. So you would repeat something several times. Welcome back from Future Me, and I think this should end the second part of this video, and it is a good segue into practicing what you've been doing. Try to figure out how one could add a 3rd player or something similar like that. And in the next video, we'll have a look at how we can repeat things when programming, which we've already hinted towards in the first introductory video. And I'm looking forward to seeing you in the next video.